Chapter 6 Estimation. The learning outcome for this chapter is the student should be able to identify the use for Z-test and T-test procedure in solving estimation problem. The second one is construct point and interval estimation for mean. The third one is to determine the sample size for mean when we are given the maximum error. Previously, we know that statistics can be divided into two types, which is descriptive statistic and inferential statistic. This estimation is the starting point for the inferential statistic. We can define inference as a methodology in drawing a conclusion about population parameter from sample statistic. For imagine, we have sample data. From sample data, we can come out with the sample mean and sample standard deviation. We want to estimate the population mean and population standard deviation. The process in estimating the population parameter from a given sample statistic, we call it as inference. Inference can be divided into two, which is by using the estimation or another one here by using the hypothesis testing. This video, we will focusing into the estimation. Hypothesis testing we will discuss in the next video. For the estimation can define as a procedure by which the numerical value are assigned to a population parameter based on the information collected from a sample. For estimation, we have two types of estimation, which is by using the interval estimator or by using the point estimator. Point estimator and also the interval estimator is come from data for sample statistic. We have here sample statistic, and then the sample statistic we will use to estimate the population parameter. Sample statistic we can define as the estimator, which is used to estimate a population parameter, where this population parameter will be our estimate, which is the value assigned based on the value of a sample statistic. The process to define sample statistic to the population parameter, we call it as estimation process, where the process of estimating a population parameter based on sample statistic. For example, one lecturer wants to estimate the average time taken by all students browse internet per day, meaning to say that the lecturer wants to estimate mu. Mu represents average time taken by all students browsing the internet. So then, a sample of 25 students was randomly selected, and from this 25 data, we see that the average day spent is 4 hours to browse the internet, meaning to say that now we want to estimate the population mean, mu. So now what we have only a sample data of 25. So from a population, we took out a sample of 25. They are going through a process of sampling. We want to estimate population parameter, which is mu. Our estimator will come from the sample statistic, which is X bar. From the data, we can have your X bar is equal to 4 hours. So how to estimate the mu from the X bar? So therefore, we estimate the true population mean, which is mu also will be equal to 4 hours. So there will be two types of estimator. Either we are using the point or we are using the interval. The point estimator here, we estimate the value for the unknown population parameter by using a single value. The error associated with the point estimator, we call it as margin of error, which is equal to plus minus 1.96 sigma for X bar. which is standard deviation for sample mean, where is equal to the standard deviation for the population divided by square root of n. Another way to estimate is by using the interval estimator. By using the interval estimator, this time we estimate the value for the unknown parameter by using the interval. And then the error associated with the interval estimator will be equal to the Z alpha over 2 sigma for the X bar, where we call it as maximum error. For the example number 2, you are given the sample statistic, which is your X bar equal to 158 centimeter. We are given the population parameter, which is sigma equal to 6.5 centimeter, and the sample size is equal to 100. Question asking to find the point estimate for mu. We need to say that here, to estimate the mu must be based on the X bar, mu population mean, estimate based on the sample mean, which is equal to the 158 centimeter. The margin of error here is equal to the plus minus 1.96 standard deviation for the sample mean, which is sigma here is equal to 6.5. The sample size is equal to 100. It will give the margin of error equal to plus minus 1.274. For the interval estimation, there will be 3 terms here to be considered. The interval estimator is the interval where we construct is around the point estimate, and then we can say that in that interval is likely to contain the corresponding population parameter in this chapter, which is mu. So in order to construct the interval estimator, we must have the confidence level. We denote as 1 minus alpha. So confidence level here is stated how much confidence we have that this interval contain the true population parameter. The complement for the confidence level is significant level, which is alpha. Alpha here is to measure of how strong the sample evidence must be before determining the decision. So, meaning to say that here, in order for you to construct the interval estimator, you must have your confidence level value. For example, how to figure out the confidence level, the significant level, and their corresponding Z value. For example, once you have your confidence level 95%, so what is your significant level? Significant level here will be the complement for your confidence level. Meaning to say that here, if let's say you have here bell curve, we know that the total area under this bell curve here is 1, which is 100%. Confidence level is the area surrounding your mu, which is equal to 0 here. So the significant level here is the remaining area left. We need to say that if at the middle here is 95%, the 10% will be distributed equally to the right and also to the left part here. We need to say that here for each part will consume 2.5%. So your significant level will be 5%. So then, in the normal distribution table, you need to find the value for the 0.025 from the table and figure out what is their corresponding Z value. So it shows is equal to 1.96. The further left is negative 1.96. The further right is 1.96. Okay, The same thing here, if let's say you have confidence level 97%, meaning to say that at the middle of your mu here, consume 97%. So the remaining 3% will be distributed equally further left and also further right, where each area is equal to 1.5%. In your Z table, you need to find the closest value to the 0.015. You can see here is equal to 2.17. The same procedure when you need to find for a confidence level 99%. So now, to estimate the interval estimation of a population mean, which is mu, it considering two cases. The first case, when your n is large, which is more than or equal to 30. The second case, when your n is small, which is less than 30. Focus on the large sample size. We have two sub-cases, which is either standard deviation for the population is known or standard deviation for the population is unknown. If you are given the value for the sigma, meaning to say that now your confidence interval will be constructed by using this formula. But if let's say sigma is not given, we are using almost the same formula except that sigma will be replaced with S, where represent the standard deviation for a sample. But different case happen for the small sample size. For small sample size, again, we have two sub-cases. Either sigma is given or sigma is not given. If let's say sigma is given, meaning to say that now your formula is the same as the large sample size. But if let's say sigma is not given, meaning to say that you need to find the S, standard deviation for a sample, meaning to say that now the formula using will be here. We cannot use Z distribution, now we need to use T distribution. T distribution meaning to say that you need to have your significant level, and then another one here, you need to consider your sample size minus 1. There we call it as degree of freedom. Okay, so now what is the factor which is influence the width of a confidence interval? We know that to construct the confidence interval, this is our formula. So for this formula, we know that here it is depends on the standard deviation, the confidence level Z here, and then the sample size. But standard deviation here, we cannot do anything. The value here is uncontrolled. This is based on the data. So in order to control the width of a confidence interval, you need to adjust the value for your Z here, which is obtained from the confidence level. So from this formula, we know that as the value for the Z increase, meaning when the confidence level increase, the large for the confidence interval will be more. But if let's say for a sample size is going inversely proportional to the confidence interval, meaning to say that here as your n here is increased, meaning to say that the width for the confidence interval will be decreasing. So now this is the normal distribution table, or we always use it as Z table. Remember, the curve will be bell curve. And then the value at a middle here, where the value of a 4 decimal places here represent the area to the left of Z. Meaning to say that now here, if let's say your Z equal to 1.04 here, your Z is equal to 1.04. So from this table, we know 1.0 will be here. And then 4 here at this column. So it will give you equal to 0.8508. But if let's say question asking for the more than, meaning to say that we need to use the complement part, which is 1 minus less than, which is will give you equal to 0.1492. It's quite different with the T distribution table, or we call it as T table. In the T table, we know that you have here degree of freedom, and also we have the T value. The subscript for T here is your alpha. Okay, then the curve will be also bell curve, but the value for the alpha here, we represent the area under the curve, meaning to say that now the value at the middle here will be the value of T, where alpha here is represent the area under the curve with their corresponding degree of freedom. For example, we have here degree of freedom, df, and minus 1. Sample size minus 1. The significant level will be our alpha. Then you are given alpha is equal to 5%, which is 0.05. N is equal to 10, meaning to say that degree of freedom is 10 minus 1, which is 9. So you looking at the alpha 0.05 here, and then you go to the degree of freedom 9. So it will show you equal to this value. But if let's say which alpha is 1%, 0.01, meaning to say that okay, this is your alpha. Then your N is 20, meaning to say that your degree of freedom is 19. You go below until you see here the T value 2.539. So this 2 value here is representing the value on the horizontal axis. Then, for example, you have here confidence level 90% with a sample size is 10. Your T curve will be bell curve. Confidence level is 90%, meaning to say that area at the middle surrounding 0 here is 90%. So the remaining here is 10%, meaning to say that it will distribute equally to the right and left. So each is 5%, which is equal to 0.05. So from your T table, alpha 0.05, and then your degree of freedom is 9. So the T value will be equal to 1.833. So the same alpha, but you go further until your degree of freedom 24, you have here the value for T 1.711. But if let's say you change the confidence level to 95%, meaning to say that here the 95% the area will be wider at a middle here. Meaning to say that the remaining 5% will distribute equally left and right, which consume 0.025. So from the T table, alpha 0.025, degree of freedom here is equal to 9. The corresponding T value is equal to 2.262. You go down at the degree of freedom 24, you have the T value here is equal to 2.062, and then you can check the remaining confidence level. The next example, in a 64 randomly selected hour of production, the mean and standard deviation for the number of acceptable pieces produced by the automatic stamping machine is 1039 and 146 respectively. Question. Here, information you take out will be these three. Then, question asking to find the point estimate for the average number for all producing by automatic stamping, meaning to say that you need to estimate the value for the mu, meaning to say that you will compare the mu with the X bar. So mu estimated equal to 1039. Point estimated. Then the second question asking to construct the interval estimator with a confidence level 99.2%. We are in the first case because n here is more than 30, meaning we will use Z table. So in the Z table here, we are using this formula. Okay, so we are using X bar 1039 at a confidence level 99.2%. So referring to your Z table, check the closest value to the 0.004. We give you equal to 2.65. And then as given and also given, substitute the value and then do a simple calculation. We give you equal to this interval. The next question is about the 4 crashes of a 1300 cc car, and then the insurance found out that the cost of repair will be this value here. And then you are given the standard deviation for the repair is 700 ringgit. Then the sample is normally distributed. Okay, you are given the sigma. And then your n here is equal to 4. And then you have the data. You are not directly given the sample mean, but you can find the sample mean from the data, which is equal to 2042.25 ringgit. So now, it is fall under the second case where your sample size is small. But at the same time, the sigma is given. Meaning to say that here we will using the Z table. So then, complete the point estimate. To estimate the population mean cost, meaning to say that now, we calculated the population mean by using the sample mean. So we can say that here mu equal to 2042.25 ringgit. Point estimated. Then you need to construct the confidence interval with a confidence of 95%. Then interpret this interval. So because of the sigma is given, so we are using the Z table. Okay, substitute all the value for the X bar, Z, sigma, and also N. So we can say that the interval here will be these two values. How to interpret this interval? So we can say that here we are 95% confident that the true mean cost of repair on the car is between those two values. If we change the confidence level to the 90%, then question asking to construct the confidence interval. The same procedure will be using. You substitute all the values, but this time change the value for the Z here. So you see that the interval will be those two values here. So to interpret, we can say that we are 90% confident that the true mean cost of repair is between those two values. With the same data, only changing the confidence level, then we compare these two. Which one will be wider, 95% or 90%. If we sketch a number line, at the middle here is a mu. So if let's say for the 95%, our interval will be located from this value to this value. But if we change to 90%, our new interval is from this value and this value. Which one is wider? B is wider. Meaning 95% confidence level is wider when we compare to the 90% confidence level. Okay, for this example, you are given the data. You are decide to study on average how much time students spend to watch television per night. And then our random sample is 10 students. And then the result given in this table. So in this question, n is given as 10. You are not given sample mean, you are not given standard deviation for a sample, meaning you need to figure out by using the data before finding the confidence interval. So from the data, we see that here your n is 10, your sample mean 2.25, standard deviation 1.1118. Now you need to choose t distribution. Why? Because your n is small and also sigma is unknown. Meaning t distribution from the table, you're looking at a 95% confidence level. So your t you check at alpha 0.025 with a degree of freedom 9. The corresponding t value is 2.262. Then construct the confidence interval. We are using this formula. Substitute all the x bar, t, s and n with these values. So we can say that the interval will be fall within these two values. How to estimate the sample size if we are given the maximum error? Okay, the sample size n is required to estimate the population mean with a significant level and a specified maximum error. Okay, maximum error come from the confidence interval formula here, where the error given at a second term here. When you are given the maximum error with a confidence level and also the standard deviation, you can determine the value for your n by using this formula. Then, if let's say question asking you to estimate what is the sample size needed, if you are confident that 99%, the error is at most 0.25 minutes. Okay, mean to say that at most 0.25 minutes here will be your maximum error. Standard deviation we assume is equal to 1.40. So the sample size needed is, we need to determine your n here. Substitute all the value here. Error 0.25. 99% is the value for Z 2.58. Standard deviation 1.4. Then you get your n here is equal to 208.74, which is approximately 209 sample size. The next question asking to find in a random sample of 45 engineers, we estimate the mean time spent in the research. So, from the 45 data, the mean x bar is x31, standard deviation s is 5.5. So, therefore, maximum error determined for a confidence level 97%, we give you equal to 1.7792 by substitute all the values here. But if let's say we want to find the sample size, when we have the 99% confident that mu is off by at most 3 hours, meaning 3 hours will be our maximum error by assuming that standard deviation for a population is 4 hours. So then, we substitute the maximum error, the Z value obtained from the 99% confidence level and also standard deviation. We know that your N here is 11.8336, which is approximately is equal to 12 sample size. And then, how to decrease the width of a confidence interval? Remember back how to construct the confidence interval? This formula. The width is based on the second term here. So at the second term, we have here Z, which is corresponding confidence level. We have S, standard deviation. We have N. We cannot change anything for S because S is come from our data. So then, the two possible way to decrease the width of a confidence interval by increasing the sample size N or decreasing the confidence level for